set. You didn't have your feet set and all that. You were just pressing a little too much. So just relax and stroke it in the future. All right?
Just relax.
All right. That's me as a basketball coach. I could not coach gymnastics at all. All right. So let's use this. Okay. So if y equals a times x minus h plus k, we're going to fill in the vertex squared. We're going to fill in the vertex for h and k. And then this is going to be our y and x. So 4 is going to equal a times x, which is 1, minus the x value of our vertex, negative 2, plus a negative 14 squared. What's minus a negative 2? Plus a positive. So 4 equals 3 squared, which is 9a minus 14. Move the 14 over. Whoa, that doesn't look right. What did I do wrong? Okay. Move the 14 over. Yeah, it is fine because Mr. Bierschbach did math wrong in his head. So if we add 14 to each side, 18 equals 9a. And if we divide by 9, a equals 2. So our equation is y equals 2 times x minus the x value of the vertex, negative 2, so it's plus 2 squared minus 14. So basically what we do is we still keep in the vertex for h and k, but then y becomes y and x becomes x. Okay? And that is the correct equation for that parabola. Okay? Now, let's say they asked for it in this form. You would just square this out and then do the math. Okay? But they want it in this form most of the time today. Okay, let's do that again. Here's a vertex of negative 6, 4 and an x-intercept of negative 10, 0. Well, that's still another point. So y of our xy point is 0 equals a times x, which is negative 10, minus h minus a negative 6 squared plus k plus 4. Okay, now we're solving for a. So 0 equals, if we go plus a positive, we get negative 4. Negative 4 squared is 16a plus 4. So if we move the 4, we subtract the 4. So negative 4 equals 16a. Divide by 16. A equals negative 1/4. So our equation is y equals negative 1/4 x plus, because it's x plus 6, because it's x minus a negative 6, so x plus 6 plus 4. Now, if a is a negative number, what do we know about the parabola? It opens down. Here, a was a positive 2. It opened up. Okay? All right. So this one has a parabola. We don't even have to do it because it's like the last two problems. And so you just plug in appropriately and find an equation. Okay. Linear correlations. If you look at these, they look like they're sloped positively. I'll have a positive slope. The closer they are together, the stronger the correlation. So would this be a strong positive, a weak positive, a strong negative, weak negative, or no correlation? This would be a strong positive. Okay. So, if we have a problem like this, where we have age of children and how much they weigh, okay? Notice how as we go up in age, what is their weights in general? Not all of them, but in general, they're increasing. So it's increasing, and it would look probably something like this, because this is all over the place. This 18, this 23, and then we're working our way up. Well, whoops. All right, I gotta go like this. So what kind of a correlation do we have here? For the most part, it looks like fairly strong positive linear correlation. All right. A market sells cans of soda pop in machines. Now, they figured out their average sales were 26,000 cans per month if they sell 50 cents each. Every time they increase by a nickel, sales drop by 1,000 cans. They want to maximize their revenue. Okay? So, whoa. So, at 26,000, they're making 50 cents a piece. Okay? So they're making basically $13,000. Now, if they increase the price by a nickel, so at 55 cents, they're only selling 25,000 or 25,000 cans. Somebody on your calculator, take 25,000 times 55 cents. So, even though they drop sales by 1,000, the nickel increase increases their profit. Now, are we going to have to do this for every single nickel increase to figure out where they maximize their profit? And the answer is no. What we can do is say, well, we'll take 26,000 cans and we'll subtract 1,000 cans for every nickel increase. Okay? And so our sales are 50 cents, or our price is 50 cents plus a nickel increase for every nickel increase. So if we have one nickel increase, then we go down by 1,000 cans. If we have two nickel increases, we go up by 10 cents and down by 2,000, and so on, which is this equation right here, right? So that's the equation we're going to use. So then we grab our handy-dandy graphing calculator, which I had mine up, but I must have closed it. So I'm going to grab it again. VTI, VTI. Okay, so graphing calculator is up. So in my graphing calculator, I'm going to, and that y2 minus y1 is turned off, so it's not going to matter that much. But I'm going to put in this equation. I'm going to go parentheses 26,000 minus 1,000 x, parenthesis. Thank you. Throw another 0 in there. And then I'm going to go 0.5, which is 50 cents, plus 0.05 x, parentheses. Now, if I just try to graph it right now, I'm going to get something like that. I'm not going to see what's going on, okay? My y values have to be in this 13,000 ballpark, okay? So I'm going to change my window. Now, I'm not going to have that many increases in price, so the negative 10 to 10 is fine. And actually, I could go like negative 2 to 10 and be just fine. But my Y values are going to be up there a ways. If this is 13,000, I'm going to make this like 18,000 and just see what my graph looks like. And oh, there's my graph. Okay. Now, it does hit a maximum here because you can see it starts going down right at the end. So we hit a maximum somewhere right in here. So to figure out what my maximum is, I'm going to go second, trace, and I'm going to calculate my maximum, 4. I'm going to go to the right a little ways, so I'm still to the left of my maximum, and hit enter. And then I'm going to go to the right of my maximum value, and hit enter, and then hit enter again to find my maximum value. If it's 7.999999, I'm going to have 8 5-cent increases, which means 8 5-cent increases is how many cents of increase? 40 cents. So I should charge 90 cents a can. If I charge 90 cents a can, what's my revenue? Well, you put 8 in here and 8 in here, and you figure out your revenue. Okay? Good enough. Okay? A baseball throwing machine throws a baseball straight up in the air, and then it comes back down again. Okay? It throws it straight up with an initial velocity of 64 feet per second at a height of 5.5 feet. It's 5.5 feet off the ground. Okay? So, for our equations for throwing things up in the air, okay, in feet, we get y equals, or h sub t, the height equals, feet. Now let me think again. That would be, because in metric system, it's negative 4.9 t squared plus the height times the initial velocity of t plus the height. So, feet per second. Gravity in feet per second. I think it's 32. I think it's negative 32 t squared plus the initial velocity was 64, and then you put a t behind that, plus 5.5. Okay, let me see if that's the equation. Oh, negative 16, not 32. Okay, it's 32 feet per second, and you go that. Okay, so for all problems with meters per second, you use negative 4.9 because that's the acceleration due to gravity. Because gravity is negative 9.8 meters per second squared, and it's 1/2 of that in the height equation, plus your initial velocity upward, plus how far you were up. Okay? So when we're dealing with feet per second, the velocity due to the acceleration due to velocity is negative 32 feet per second, so you go 1/2 of that. And then this is your initial velocity, and this is your starting height. Okay, so this is your equation. To find your maximum height of the ball, okay, to find the maximum height of the ball, that's when your final velocity will equal 0, okay? that's when your final velocity will equal 0. So what we have to do is find the maximum point of this graph. Okay, so then we type that in. Y equals, clear, negative 16t squared. Yeah, x squared, t squared, same thing. Plus 64x plus 5.5. We graph that. Oh no, I can't see my graph. Why? Well, my window is wrong. That ball isn't going to go 18,000 feet in the air. It might go 180 feet in the air. And now I can see the ball. Okay? So I go second trace, find the maximum, go to the left of the maximum, enter, go to the right of the maximum, hit enter, and hit enter again. The maximum height of the ball is 69.5 feet. It happens after 2 seconds. Okay? So that's the basics of what you guys are doing today. Okay? So if you get a metric problem, it's negative 4.9 t squared, your velocity and your height. If you get a feet problem, an English units problem, it's negative 16 t squared, then your initial velocity times your t, and then your starting height. Okay? So that's how you set it up. Graph them on a graphing calculator so you can